walked up, he's the same height as Isaiah. That was Isaiah without looking up. I was trying to guess. Weird.
He's in geometry right now.
Oh my gosh. Another person.
Who?
David.
David
David Gordon.
He's leaving?
Yeah.
This?
Oh, this is the robotics.
The modern principle.
Robotics. Hey! Here we go.
About.
You're not just looking at the table. Welcome, everybody.
When I called, but
Final day of Code for Lunch here in the library. That's right. I'm Mr. Moriarty, your media teacher, friendly neighborhood broadcast club advisor. And this is the live stream. So we have a special demonstration today from the awesome folks at Somerville High School's robotic team. Look at these guys. Yeah. Technology. This is Elon. Say hello. I can't make a move. Well, you guys can make a move. They're going to give us a demonstration, so if you guys want to stay around and check it out, we're going to be live streaming the whole time.
Gordon's leaving. Good job with your husband.
Oh.
Here we go. All right, so if you have any questions, feel free to type them in the little chat filter, and we'll see it. Other than that, welcome. We're going to check this out. Oh, look at these guys.
Timer kind of works.
Kind of? What do you mean kind of?
Ready?
Kind of.
There it is. That's Elon right there. Look at that guy.
Baxter, can we make reverse time like you are watching?
All three down, talk to your teacher, get a note. You can check us out. And Nolan, you're going to be recording most of this, them talking about it, all this other stuff. Hey, guys, come on in. All right. Yeah. I don't know if they're gonna actually. Are you guys gonna be? No. Want to move this table?
Sure.
Yeah, if you pull it back. All right. Hello. Guess what? You get to do.
No.
Yay!
Nolan, switch.
Nolan, you have run a camera for a while. What's up, everybody? Look at all these people coming in. Say hi to the live stream. Look at all these folks. Oh, is there Mr. Semple? There's a Mr. Semple. A wild Mr. Semple appears.
Gabriel was
Good job videotaping over there at the assembly the other day.
What?
Oh, back to work.
Back to work, my friend.
Yeah.
Where's your shirt today? I don't know if you're official.
In the wash.
You have a shirt too? Hey, just come over here. Give me your shirt.
Oh, yeah, we did get you a shirt. We need to come by. Oh, I got this. Well, actually, I couldn't mind. This Ross had an intro. Yo, what size shirt? 2X, you got it? I have 6. That's where the Okay, how long you want to wait? Yeah, this was not. The other one is this one just screens. Okay. So. Okay. Jeff, unwind this time. If you stop moving it. Wait, so what's the second? Where's the yellow guy?
You want me to change it?
No. So what is climb right now?
Climb is 7.
The 7 is 8?
Yes.
That's fine. And then stop is 2?
Stop is 2 and 1.
On this trick.
So,
no, wait, what is 1?
broadcast
I don't even know what 1 is.
Just use 2.
Yeah. Once you're ready.
I'll wind
All right. So what I want you guys to do, not a lot of talking on the film.
Okay.
I don't want to.
We're just gonna
What I want to see is
how
see.
Only 17 minutes.
Yeah, we're going to go 17 minutes. You don't want 17 minutes on the side, but I want you to focus on the robotics, focus on these guys talking, and you're showing the live stream. So make sure that you're constantly aware. If you want to switch the camera around so that you can see what you're seeing, you can do that if you want to. Make sure you how to do that.
No, I know how to do it. I think it's easier to do this.
Yeah, we're gonna go through tripod, shotgun mic,
an XOR pin and to an aux cord.
Back away.
And,
Back away.
what else?
Let's try this.
Do you want to do this or should we send somebody?
Vector. 7 isn't working. Did you do one?
So, guys, you can, whenever you guys are ready.
Right there.
Nice. See, that's the kind of stuff you should be filming. Don't look at me.
One second. We have an Ethernet cable dangling off the bottom of the robot.
That's not good.
That's for probably gone.
You should have said something,
Yeah,
Parker.
I'm just gonna tuck that in. There and no, it's on there until we ran out of access in front. No, that big one. That one is. That is. We have a different one.
Adrian, just make it. This is the right way to. Right.
No, is that?
Wait,
No, we want it above.
Above.
We want these above because
Yeah,
had a
right,
time
'cause
it
we
gets
had
caught
to-
under here and it snaps.
Yeah, and we had to tape it before.
Yeah, that's great.
It should be fine though. Yeah.
Oh, how's it turn?
Well, only certain wheels spin at certain times. So like one front one will on the left or back or right. But some
The wheels don't.
the wheels don't move.
Only certain ones will be on.
Exactly. Yeah.
Okay.
Let me see if I remember it.
What do you want me to send to me on the phone?
Remember that really long one that had all the values here?
Oh, yeah, I have it.
So I think that highlight here. I think I'd love to have you up again once you know what your challenge is too. You know, want to come back. We're probably gonna have through in a few of a laid back. Guys. driving around, looking down. You come up to it.
Well, basically, it's going to how our economy's closed here, and then we're going to and there's this a software called Grip, which is kind of like Flash, and like
Yeah.
Flash, but like more like
Nice.
and we can do
Don't buy anything. Not to buy anything. Well, where's the money? I have $100 in it. I have none. Like 3 in the morning. Why do you keep on dropping?
Oh,
Because
I was partially like how it. When you put it in, like during the competition, you have to put it down on the ramp and it will shoot. That's why we have those like bar type things. So it bounces off and it goes to the right position.
How's it hurt?
I know it.
yeah.
Because if you look at the skeleton, it basically looks like they're crouching like
Like they're
this,
squatting.
and then there's just like fat all over.
Hey, I hope you know you're on live.
Wait, is this on the YouTube? Wait, do we have another
live
laptop?
streaming?
Do we have another
I'm so
laptop
happy
we can
we
open
got
up the stream on? I don't want to disconnect from the Robotics to watch the stream. Is that a bad idea?
Yeah, that's a bad idea.
Yeah, it is.
Yeah.
Isn't it? Yo.
Hi everyone.
Oh,
Where's Mr. Moriarty? I think he was going to get some soup.
he was somewhere.
I'm supposed to be here today.
Wait, can I run Jeff over?
No.
No, please.
I love he's getting live action.
Unplug the battery.
Hey.
Use it in conversation. Yeah.
I'm not gonna.
Ow.
Why? Descend. It descends 10 times slower than it climbs because we don't want to have to touch it to get it off. Stop. Triple boost. Speed control. So just go up, go down. Stop.
What?
Triple boost.
So stuck?
That one stop.
No, stop. Okay.
Yeah. No. So when it's so like, back, when you get to the top, you press 7. When you're almost to the top, you press stop. It goes down 10 times slower, and then you can press that stop.
What again?
No.
So what are we waiting for?
So we're waiting for people to keep our class.
Oh, I see. So there's actually students coming in. There we go. Yeah,
Probably in the back right. No. By the back room in the corner down there, way down there.
Yeah, I just did that. That was probably devastating. Probably.
No, it's on.
No, it is on.
It's on. It reset.
Yeah. He pressed it.
He pressed it just quick enough that everything turned on, but not that it latched off. That's like the meanest thing you can do. I saw the lightning flash. Okay, I got.
We're just staying here. You're ready to come by. We're just seeing how.
Why do I have the robot now? That's not good.
Only block 4, but like, this isn't dead. You get it?
This
Like, come on.
You're done.
Yeah, we're staying here block 4. Like a 1 hour and a half plus. Like, when you go.
Maybe they're trying to
Ever since I got trapped in the middle of the classroom, I'm like,
on editing.
so how many people are watching this film?
Back up a little bit, dude.
That looks like a bad message.
Hey, Owen, you're a bad error message.
Back I don't have comms.
Maybe, wait, what?
I don't have
You
comms.
connected to Wi-Fi?
I am connected to the Wi-Fi.
Are you?
Small number of
Really?
students coming over to view now.
Jeff, what did you do? Jeff, what did you do?
Red button.
No, not that.
I saw him hit it.
No, it's a different
How many up?
Whoa.
Hey guys, so
Press it left.
pull up from there.
This is everything.
Okay, oh, you actually would like to send?
So that would be cool, but I mean, obviously you don't.
But you're the one who was lying on the floor.
Because I was taking photos.
This kid.
And then travel up the angle. You said that.
Yeah, because I restarted doing it.
Well, I finally got my email about the NFL.
To the robotics club coming today and sharing all your hard work. So let's hear what you got going on.
Oh, okay. Is it up?
We're working on it. Oh wait, comms enabling. You got driving
Line it
this.
up in front of the target. Okay.
No. It's close enough.
Well, I haven't feed yet, so.
Refresh. Wait, let me just like,
So you guys want to tell us first about your robot? Or
Okay. So we are the robotics team, Somerville High School robotics team, as said. What we do is we compete in global competitions where we have to build a robot to complete a task for each year. So this is our robot from last year, which was steampunk themed, and we had to build a robot that could take gears like the one you see in the very front and deliver them in health and power airship.
So you said take gears and help power. What did you say?
So we had to collect gears and you put them on a peg that's used to power the power.
Oh, okay.
So what we're going to do today is we're going to show you, first we're going to show you how we find targets and vision, because in robotics there's a focus period where you competition that you have to have the robot that you want to code to accomplish tasks that are not successful. So we have to have clear vision so that we can see certain targets and stuff, like the one that you see right there. What we do is we have an LED ring around our camera that shines on retroreflective tape, and then we use code that I'm going to set up right now to find that target. And then so first, what we want to do is we're going to connect to the IP camera that we have on board. It's right there. It's on the camera. I mean, on the robot. So connect to that. Then we'll have so what this program is, it's called Grip, and it's a pretty friendly user interface for. There's different modules and stuff that let you mess with things to find targets, and then eventually you can generate code from it that you can actually use. So what we're going to do first is we're going to do a resize. It's open source. It's built by like a official company, so it's not very good at not crashing, I guess. So. So how retroreflective tape works is that whenever you shine a light on it, it bounces back that light directly in that direction. From any side that you're on, the light will come back to you, come back directly to you. So what we do is we use that to find certain colors and certain lights, and then we turn target and then get data from it that we can use in our program.
You can see that these are the two stripes of tape on that target. They're really bright because it's bouncing all the light back that's hitting them.
Oh, look at that.
From our light run controller.
Okay, so first what we're going to do is we're just going to resize the image to about half. So it's easier to work with. As you can see right there. And then what we want to do is we want to get a blur in here. And the reason we want to blur is because in these images there's going to be a lot of noise, and that can hurt our abilities to find a target. So if there's too much noise, we can blur the image to reduce a lot of that noise.
Would the lights out be better?
No, it's fine.
Okay.
Because it's even brighter during a competition. So. Cool. We don't really know what we need. And then now what we're going to do is we're going to do an HSV threshold. And that means we have a hue, saturation, and value. So what that means, it has a large range of different colors and things like that we can like solo out to find as targets. So we just connect. And how Grip works is you connect each of these pipelines, as you can see. So right here we have the first image. It's just a plain sort of white. If everybody wants to come around, you can sort of see it on this monitor.
Okay. You can come around and look on the monitor, guys.
I think you can like get out of the way. Just so you can really see. So, okay. So as you can see, it's just white right now. What we're going to do is we're going to mess with these values until we can figure out where it is. So this is... One second. It's moving so low, isn't it? It's only normally Wait, I think it's because... Oh, and I think it's because you're using the feed as well. Yeah. All right. No, because like I'll get them to stick over.
Is it recording?
No.
Everybody else new coming? We're the small high school robotics team. And we're going to be showing off different problems in this programming and happy hour and coding that we encountered on the robot. What we're doing right now is we're trying to find targets. We're trying to find these two people on this wooden target with that camera. We're trying to so what we got here is a program called Grip, and what it really is it's kind of user interface that allows us to use different modules and you can use them as so what we're going to do first is we resize the image, so it's about half the size, and easier to work with and takes less processing power. And then we've also added blur, which helps to reduce noise in the feed. And we want to get rid of noise because it can be optical in front of the target. And then we've got HSV threshold, which stands for hue, saturation, and value. What that does is that gives us a wide range of color values that we can try to fill out. So in this case, what we're doing is we have an LED ring around the camera that shines on retroreflective tape. What retroreflective tape does is it reflects whatever light is shined at it back to its source. So from whatever angle we're shining the light on, the light will reflect directly back. So what we're going to do is we're going to use that and we're going to start essentially messing with these values until we get Q. So we just press on with this, you can sort out everything. You see that thing as here and here. Can we see that first? So we're essentially we want to do trial and error stuff. So,
Black would have the other computer that we were in the way. Oh, I moved it because I was pressing my desk.
Oh.
Yeah.
What happened?
It's not very reliable. It's not hard to get back. Okay, so we've already got a lot of it right there. As you can see, there's two rectangles that we're trying to just solo out. Alright, you pretty much got it right there. So as you can see, there is right here and here. Those are the two pieces of retroreflective tape, which means we've got the target. So now what we want to do is we want to find the contours of these, which is essentially the outline. We want to find, there's a find contours, or that's not the contours, sorry. There's a find contours module. And then we want to filter these contours. So you know exactly what they're in. And then if we look at this, here's this image, and we have two outlines of two targets. They're colored in yellow and red. And we can use that now to publish. We can publish this data now. So using these contours, we can get a center point. Okay, everybody, if you want to see, there's a feed right here that we're actually working with. So using these two outlines we have, we can find a center point for each target. We can find the area of the targets. We can find the width and the height relative to where the camera is. So to actually get that data, we have to publish it to what's called a network table, and then we can receive that network table in our robot code and then do stuff with it. So if we want to check, right now it should be working, sending everything. So if we want to check data, if we want to go to this tool that's given to us, and then we want to input the IP of the camera. Since we gotta open it first. Right, so we have that. Now we're gonna use the IP of the camera, just that, and then we're gonna publish, and we should be getting data. Yes. Yeah, so we have our data right here, and then we can use that in the robot. So that's essentially how vision works on it. Finding the targets. I do an autonomous program, but nobody has the time. So it takes a while. So yeah. All right. So we're done with script. I think now maybe something a little more interesting, which is. Seven. 11. There. I'm going to do everything. I'm just going to show them what we're actually going to work on, and then. Okay. Let's play this. Table. Okay, so now we're going to make a program that allows us to drive the robot forward for X amount of seconds at the certain speed that we can set. So right now I'm just going to show you. Right now I'm going to show you what the program is, and then we're going to write it together. So we're going to just press 11. So essentially that. Press it and it can move forward. But it's not as easy as you think. So, okay. So you want to see that the code is right here, and then we're writing another one of these things. So anyway, okay, so what we're going to do first is make a new class. And in the programming language that we use for this robot, which is called Java, Okay, so in the language that we use, you have these things called classes, and what a class is, it's a it's a file that has different. The definition of a class, Adriana.
A class.
A class is
It's basically like kind of like a box you put inside the class.
Yeah, so a box that you can put instructions in. Yeah. So we're gonna make a class. We're gonna demand in that class. I don't know why it's not.
Commands that go together.
That's a different kind of class. So there are. So we have commands, and that's the actual command itself, and we can do command groups, which is another kind of class where you put more than one command together, and then you can execute that, and it executes every command inside of it.
How fast have you walked that?
How many feet per second? It's like turbo boost or not? Turbo boost, like 13.
Yeah.
I think probably around 13 feet per second.
Wow, 13 feet?
Yeah, and then next year if we not to hurt you.
Yeah.
13 feet.
There's some teams that have accidentally broke like a wall in their workspace just by driving robots too fast.
So
I think
right is one
I think next year
13 feet. That's amazing.
next year what we're gonna be doing is we might be building our own drivetrain or our own basically chassis for the robot, and with it we probably get speeds of like 19 to 20 feet per second. No, 19 to 20. 120 would be insane.
Still.
Okay.
Whoa. That's amazing. So you guys got your kit. Did you get this kit like in October or something?
January 6th.
Oh, you get a new kit in January?
Yeah, we get like random features in it. You also get the little drivetrain with the metal on the bottom of the motor.
I'm just trying to explain to the audience that a little bit about it, and then you have a certain amount of time to build your robot to do something. They're going to give you a job for it. Like once I saw the first robotics had to lift up a soccer ball and get it over a.
So what we do is in January we have 6 weeks to build a robot and program it, and we use that to compete in large events around the world. I think last year we went to St. Louis for the World Championships in April.
So did my school. I used to work at Brighton High.
Yeah. So what we do is we build a robot to that it can complete that the organization first gives us each year. So this is a robot from last year. Yeah. So what we're gonna do? Okay. So if anybody wants to look at this, what we're gonna do now is we're gonna make the program that allows us to drive forward that we just saw in the last one.
They're adding words if you want, words and numbers right here.
Yeah.
That are gonna make it.
Come
Come look at the that are going to make it drive forward.
Yeah, so we're gonna make it drive forward for X amount of seconds.
Okay.
So what we're gonna do first is we're gonna make a timer because we need a timer to So what we're doing here is we're creating a new object. So we're creating a new object that time how long in this case, we need to time how long we drive for. We need to time how long we drive So,
So far.
so what we do now? Now what we're going to do is we have to make sure So now we have and then we want to set it up so we know what can happen. So when we get to
Money, best. Mom, check.
okay, then we can like sort of gather around the
Gather around just in this perimeter.
Plenty of seats over here, guys. Around the table over there. Bring chairs up. Super great.
Okay. And now we are the Somerville Robotics team. We build robots every year. Worldwide so we started last year. And we figured to set double competition. So last year we figured six. Essentially we have video games every year. There is a new theme for a game. We have to build a robot that can accomplish this task. So last year was steampunk themed, so we had to power a airship. So what we're going to do today is we're going to show you how to make a simple program that allows us to drive the robot forward for X amount of seconds. So I'll just show you. So I press this button. Essentially just do that, which seems harder than it, So really showing everything already on this screen. So people can't see really well. You might want to come a little closer and probably around the screen so you can see that. But you're fine. So what we're going to do first is we're going to so for the robot, what we do is we use a programming language called Java. It's a pretty highly functional used by companies like Apple, Google, all the big tech. So what we have to do first is we have to create a thing called a class. The class is essentially it's a big box that we put with instructions. It can run commands and all that. So we're in the command class. The new class called library drive, so that's what we use here. And so what we need to do is to first think about what we're going to do in this. So what we need is a timer, right? And then we need to actually get a command that tells us what to drive. So we have the command do the driving, but first we need to find a timer. So what we're going to do is we're going to create something called an object. And an object is essentially
you're taking something from an import from the clip file and you're making a variable.
So an object is essentially sort of like a variable or something that you can use. You can use to get information. So what we're going to do is we're going to create what's called a timer by doing private timer is equal to new. Or I have to use a name. So timer equals new timer. What we've done here is we've declared a new timer, and okay, so what we've done here is we've declared a new timer. So we have a timer that will keep track of how long we've been doing a certain task or whatever we want to do. So what we're going to do next is we have to find two more variables that allow us to determine the speed of the driving and how long we're driving. So we're going to make two variables called doubles, and what a double is it's essentially a number with a decimal point. So it's a special kind of variable in Java, and if you want to use any numbers with decimals, you have to make it a double. So we're going to make one called driving speed, so that's how fast we're driving, and then we'll make one called driving time. Okay, so now we have two variables, or we have three things. We have a timer, see how long we've been driving for. We have a variable that allows us to set the speed that we're going to drive for, and we have a variable that allows us to set how fast we're going to drive. So now what we have to do is we have to initialize these variables. And to do that, it's you have to do this dot driving speed equals driving speed. It seems repetitive, but Java makes you do it. I'm not really sure why. Driving time equals driving time. And then, so we've initialized these two variables, and now what we want to do is we want to actually, we have to use, we need to actually implement what's called a drivetrain. So a drivetrain is a subsystem on the robot that we've programmed to essentially control the wheels and how fast we can drive, or just how the wheels actually move. Implement that by typing requires. What we're doing here is we're calling the robot class, which is the first class that runs, which is the first set of instructions that runs when you start up the robot. And we're finding where we've put the drivetrain. Where we put the drivetrain. Okay, so that's done. And then what do we want to do now? We want to, so
I want to see the thing move.
Yeah, can we run it?
well, there's still a few. So, okay, so now what we have to do is we have to, okay, so now we want to make sure that the timer starts when we initialize the command, right? So we want to do timer.start. What we're doing is we're calling what's called a method. So a method is just one instruction that is coded to do a certain job. So we're calling the start method, and that's telling the timer to start keeping track of time. And what we also want to do is we want to do a reset. So this means whenever we initialize the command, it automatically resets the timer to 0. And why that's, can anybody think of why that might be important? Why don't we want? Nobody?
Burn out or hit a wall and keep going.
So okay, so why that's important is because when you're it for 1 second, But if you keep it going and we try to do it again, it'll say that 1 second has already passed. So if we want to drive for 1 second, we press it once, drives great, all right? And then we want to press it again. The timer hasn't been reset, so it's at whatever, it's probably at like 10 seconds or whatever. It says that 1 second's already passed, so it's not going to do anything. So we want to make sure that it resets every time we press it so that it knows, oh, you got to drive again. Okay.
Let's actually do a demonstration of the robot moving and climbing. Maybe.
Sure.
I'm worried about time.
Go ahead. Whatever.
Thank you.
We don't have time, so we're not going to finish this. It's good. Just climb.
So one of the things that we actually had to do in last year's competition was have it climb up a rope, and that would get us extra points at the end of the match. So this is what that is. So actually, yeah, I think it's all. There we go.
You got extra points for climbing? What about climbing speed?
One of them.
Okay, yeah, that's all I have. So. If you want to, okay, so we can give you a better sort of explanation of what it actually is and what we do. We meet every Thursday in the Fab Lab, which is downstairs. One stairs, so in the atrium, you might see everything. There's stairs that go down. You got to go down all the way into the hallway. Is anybody? Have you done the drafting yet? Okay. Well, you'll go to the Fab Lab eventually. But essentially, the way to do it. So you go down there, there's a set of stairs, go down that, and there's a hallway that goes back this way. So you that. How about there? So we meet on Thursdays every week, and then starting January, we'll see. And then we'll be pretty busy working. So if you want to come check it out, and we can give you a better explanation of how everything works, stop by next Thursday.
Some of these students may be able to stay because their class is here, actually. So if you want to do a little more demonstrating or let them try the joystick, I don't know if they can do that, if that's too much. I know, that's what I want to do. So
I can keep going with the timer.
Oh, they're headed out. Okay, they're headed out. Okay, all right, so it would be a good time for you to head out. Oh, I thought it already ran. Oh, okay, 2 minutes. Yeah, sorry guys, 2 minutes before you're done. You guys know you can go to the Fab Lab? Like, yeah? No, it's open.
Oh, God.
Come on. Go away. Don't touch the camera. Don't touch the camera. Why is it fucking touch the
Hey guys, want to come see the world? So, did you just take this out, right?
So this is here, guys. Come look up close.
Yeah.
So in the game, if you look it up, if you go on the website,
I mean, it's pretty dangerous.
Good job to my Terminators. Huh? I warned you last year. You make a turn.
I need lunch.
I mean, opposite side of the field, he's here. So like essentially like there'd be some like slidey thing here. And you push it in. And
It should.
yeah, and like yeah, but I can't do it right now. But like when this robot is driving, it's like there's enough force that it pushes it down like that.
I got
And so then this robot would go all the way to our team like this.
Barely speak with anything. Me and my best friend would sit in the back of the classroom and we would play high. And we would just like play tic-tac-toe because we didn't care.
I know, I saw them just earlier.
No, me and Desiree, we were in the same class.
Oh yeah. You guys sit in the back of the room, looked like you had your friends. I swear to God, they just sat there like this for like the entire breakdown. I was like, you guys like talk to people.
We did stuff.
Yeah, like you hung out with Josh and Megan. Megan is God out of
But honestly, I can't yes.
It's okay. A very tall, brown-haired, yellow sweatshirt kid. He's a nerd, and it's funny. Not just a cool nerd, he's a funny nerd. Covering his face without the lens. Put her hand on the lens. You can show Blair this out.
Yeah.
Why don't my kid doesn't believe in Santa Claus?
The kid in the Bruin shirt definitely doesn't approve. Let me see.
He doesn't look like he's really. I waited in line for an hour and a half to sit with that Santa Claus. Looks like he's a reject. Oh man, you should have brought him to the Brazilian Santa Claus. Yeah, yeah.
Ho. What's up, guys?
My daughter told me yesterday, like the time that Santa Claus came to the house.
Looks
You know,
like you
like
just
we
woke
were
up.
having a party and it came to the door. Because I know that was you.
You didn't say ho one time.
That's what she said.
No, he didn't.
Bruh.
Come on, man.
Oh, come on. You're supposed to do that.
I remember like we're not gonna make it. I think we just made it. 37 teams made it. We were 33. But it wasn't like one team had like 90, we had like 80. It was like basically tied.
That's amazing.
Yeah, in districts we made it up to the top. We were after the second team for the first half of day 2, and that was
The reason I'm asking is because it's a good field trip. They do a 2-day competition. In 1 year, they did it within the year.
If we got put it next to the spill over it.
Wait, is it lunch right now?
Yes, lunch 3.
No.
Here's the fun.
What? Wait, what is the lunch? Jeffrey, what is the lunch?
Meatloaf. All I can have first.
No, if we make it, this, It's gonna be in Daisy and Boston.
Oh, okay, there you go.
Yeah, so
They compete on a Friday though, a school day.
oh no, they're doing
No, it could be on Saturdays.
Wait, I think it's Friday. Yeah, no, it's Friday, Saturday, Sunday.
Okay.
We
Yeah,
set up
Friday.
after school on Friday.
Yeah, we set up
Oh,
teams like
okay.
just set up.
They usually bring a field trip because it's during school break.
Yeah. If you can't
Did you?
I did this weekend. It's amazing.
Oh, I know. I know. Thank you so much for bringing your class. Thanks for coming, guys.
You want some more? Me too. Your class is probably more important.
You deleted the code? Hidden files? Yes.
Yeah, we deleted it.
Because like, I never did just basically that and then we ran out of space. So like you went, oh, it's just the fire. So you about like how they were like games and like backups.
Yeah, they were in there. Yeah, I done that before too. I did that with TriCapture. I erased a bunch of the hidden files. We're in Windows 94 on my computer. Yeah, so you can imagine.
Wow. Same expression as this. I know.
How you enjoying the performance so far?
Thank you so much.
Okay, so we're gonna log out. Thank you guys for checking out the Hour for Code.
Did anyone?
Peace out.